Hi everyone, this is Sirius back here again with another video. Today we'll be looking at the 2019 Pure Chemistry paper, and this question is from paper 2A2. Right, so let us take a look at this question now. Some elements have many isotopes. Table 2.1 shows information about 3 isotopes of element X. So for part A, use data from the table to show that 1, 2 and 3 are isotope of the same element, and for this question 2 marks is awarded. So again, to prove that they are isotopes, what is the definition that we must remember about isotopes? Isotopes are the atoms of the same element having the same number of protons and electrons but different number of neutrons, right? So we can see that in terms of the number of protons, all of them are at 16, and the number of electrons, all of them are at 16 as well. However, for the number of neutrons, it's 13, 14 and 15, so all of them have different number of neutrons from each other. So what would then be the answer for this question? So there's 2 marks to this question, so there will be 2 points required. So 1, 2 and 3 have the same number of protons and electrons. Okay, and how many do they have? Okay, 16. Alright, so this will give you the first mark. The second point will be they have different number of neutrons. Okay, so this will award you with the second mark. Alright, so let us take a look at part B. Explain how the data suggest that the 3 isotopes have the same chemical reaction. So again, recall what determines the chemical reaction of an atom is the number of electrons that it has, right? And of course, the number of protons and neutrons actually affects more of the physical property and not the chemical property of an atom, right? So for this question, the answer will be all 3 isotopes contain the same number of electrons. Right, so this will suggest that they will have the same chemical reaction because, as I mentioned just now, the number of electrons actually affect the chemical reaction of the particular atom. Alright, so this 2 question is done for now. So let's take a look at part C. Element Y and element Z also have isotopes. Table 2.2 shows information about an isotope of element Y and an isotope of element Z. Right, use the information in table 2.1 and 2.2 to identify the element X, Y, and Z. So, how can we identify this different element using the periodic table? Always remember, we can use the proton number to identify the element because you can lose electrons or gain electrons, but you don't lose proton and gain proton. Alright, so from this we can actually use the number of protons to tell us what is the particular element. So for element X, we can see that it has 16 protons, right? So if you look at the periodic table, you will know that element X is actually sulfur. Alright, and for element Y, there's 8 protons. So again, looking at the periodic table tells you that this is oxygen. And finally, for zinc, the number of protons is 30, right? So this will tell you that it is zinc if you look up from the periodic table. Alright. For part 2, suggest the trend in the melting points of element X, Y, and Z. So what is the one with the highest melting point, and what is the one with the lowest melting point? Of course, comparing these 3, we can very easily determine that zinc will have the highest melting point because it is the only metal among the 3, right? Therefore, it has the highest melting point. So now we are left with sulfur and oxygen. So how can we determine which has the lowest melting point among between the 2, right? So we know that in terms of the molecule size, sulfur is actually much bigger than oxygen because of the extra number of protons and electrons that it has, right? So in order to, when there is more protons and electrons, there will be more attraction between these two, because proton is of positive charge and electron is of negative charge, right? So they will have an attractive force between the two. And by having more protons and more electrons, they actually have more attractive force. And all this attractive force actually requires heat energy to break them up. So more heat energy required, this automatically translates to a higher melting point, right? So in that case, we can then determine that the one with the lowest melting point will be oxygen, and now in between the two will be your sulfur. Alright, so explain your reasoning is exactly what I have gone through just now. Zinc is the only metal, hence highest melting point. Sorry about that, my pen accidentally changed to a green color. Next, oxygen and sulfur are non-metals. However, as sulfur has a bigger molecular size, more energy is required to overcome attractive forces between the particles, right? So therefore, the melting point will be higher in sulfur as compared to oxygen. Alright, so we come to the last part of the question. Which of the elements X, Y, or Z reacts with acid to form salt? Explain your reasoning. Right, so for this question, recall some of the acid-base reaction that you have learned. Right, first you have your acid plus matter, right, giving you salt plus hydrogen gas, right? This is the first one. Second one will be acid plus carbonate, right? Metal carbonate, in fact, giving you salt plus CO2 plus H2O. And lastly, you have your acid plus base, right, to give you your salt plus your H2O, right? So for this question, which element X, Y, or Z reacts with acid to make salt? Right, so you only have one answer, which is zinc, because oxygen and sulfur are non-metal and there isn't any equation stating acid plus non-metal giving you any other stuff, right? So for this question, for this answer, sorry, I'll write it here because there isn't enough space there. Okay, only element Z reacts with acid to form salt, as it is the only metal. Alright, and this is how you go about solving this question.